So to add an automatic optimization in Turbo Design 1, we can start by selecting this option here. And now we can see an optimization has been added, and we can turn on all the optimization windows and rearrange them a little bit. Yes. And then what we can do is we can start with the input parameters for the optimization, and we can see here that we already have the stream-wise loading parameters by default, and we can also add the span-wise loading parameters. So we only need to add the trailing edge values because the leading edge values are 0 and we don't want to change them anyway. And so now we can see that they have been added to the input parameters, and we can start by adjusting the ranges for each of these parameters. And as for the stream-wise loading parameters, by default we can see that the values are plus minus 10% of the original value for each of these parameters, but there is actually a machine learning driven algorithm, and which we can activate by this option over here. And what this will actually do is run a machine learning based algorithm to estimate the optimized upper and lower bounds for each of the stream-wise loading parameters here. And the reason we want to do this is we want to be able to explore a large enough design space, but at the same time we want to avoid infeasible solutions as much as possible. And so we can start this process just by clicking here. So just like that, within 5 minutes or so, we can see the ranges for all the stream-wise loading parameters have been optimized like this. And once we are done with the input parameters, we can move on to the constraints. And here we can see that the throat constraint has already been added by default, and this is actually plus minus 10% of the original value. And this constraint is basically to control the peak efficiency point for the fan. And another constraint that we can add to this is the diffusion ratio, which is indicator of the possibility of flow separation. So we don't want it to be very high, so we can actually limit it to let's say 1.7, a little over the original value. And now if we look at the project manager window here, we can see that for redesign 3, our target case, we have enabled some of these user defined parameters as well. And these are axial fan specific parameters, and for example, the work is actually indicator of the power consumption by the fan, and these two here are the diffusion ratios at the hub and shroud respectively. The overlapping is indicator of the overlapping between the blades in the fan. So one means that there is an overlapping, and then these three are actually indicators of basically a check for negative blade loading, and 0 means there is no negative blade loading, whereas 1 means that there is. And then we can actually select some of these and add them to our constraints. For example, work is important, and overlapping, as well as the negative loading parameters. So let's start with work. So we really want to constrain this pretty tightly because we don't want to change the power consumption of the fan. And overlapping, ideally we don't want any overlapping because of manufacturing reasons, for example. And of course we don't want any negative loading as well at hub, midspan and shroud. So after the constraints, we come to the objectives finally. So we can see that the total profile loss is already selected. to be minimized, and this is actually very important in axial fans, so we'll let it be here. Whereas secondary flow, we can actually remove this because something which is more important for axial fans is actually um, the leakage loss. So we'll replace it with leakage loss, and we'll minimize this, because these two have a major effect on the efficiency of axial fans. So once our setup is ready, we are ready to run the optimization, and that we can actually do by simply clicking the run option here.
We can see all solutions, or otherwise we can choose to see the convergent solutions only, which is very close to all of the solutions actually. And next we can actually select the feasible solutions like this. So now we have only the feasible solutions which respect all of our specified constraints. And finally we can see the Pareto front here, which is basically a set of optimum designs from which we can select any design for further analysis. And in fact, in this case, we choose to go with the minimum profile loss point. So we can just select it like that. And then if we select analyze case option, then this is going to design the optimized case in Turbo Design 1. And this will then appear in our project manager window like this. And now if we look at the results and compare them with redesign 3, so we can see that there is a significant improvement in the diffusion ratio as well as the profile loss, whereas the leakage loss is not compromised. And at the same time, if we look at the user-defined parameters, we can see the work has been constrained as intended. The hub diffusion ratio is also much lower than redesign 3, and there is no overlapping now as we had intended, and as well as no negative blade loading, so which looks like a good design. And now we also have some plots which we can see. So for example, the 3D geometry of the optimized design, and we can actually choose to compare it with the redesign 3 just like this. So we can see that there is quite a difference compared to the redesign 3. And if we look at the relative velocity plots, then we can see that there is quite a bit of difference in the relative velocity distribution compared to redesign 3 as well. And in fact, if we look at the blade loading plots, then we can see what actually changed. So the span-wise work distribution changed something like this. So we can see that compared to the redesign 3, the optimizer has tries to reduce the loading at the hub and the shroud. This is because at the shroud it wants to reduce the leakage loss, whereas at the hub it tries to reduce the diffusion, and at the same time it increases the work at the mid-span, because in order to maintain the overall work. And also if we look at the stream-wise loading distribution, we can see that it has changed quite significantly compared to the redesign 3. And now if we look at the project manager again, and we have these option of plotting the our performance parameters. So for example, if we select the profile loss, then we can see that the optimum design actually has a much lower profile loss. It's very clearly visible here. And if we choose to plot the diffusion ratio, for example, then clearly there is a big improvement. And also the leakage loss, we can clearly see that it's not been compromised in this process. So overall, it looks like the our optimized design is should perform well in CFD analysis, and so we select this design for further analysis and comparison with the redesign 3.